Aloha everybody, this is Gigi from Kauai Community College. In this video, we will be studying piecewise functions. So what is a piecewise function? Function that uses different output formulas for different pieces. Like in this case, you can see that there are three different pieces, right? One goes from the interval of -4 to -1, open. So we would say the function, let's call this function f of x, okay, is equal to, and we know here that it has three different pieces. The first piece here that we see goes from -4 to -1, and the function is defined as a constant function, f of x equals -1, when x is in between -4 and -1, including -4. So when x is greater than or equal to -4, but less than -1. And so that's the first piece of your function. Okay, now the second piece of your function goes from -1, closed interval, to closed interval 2, right? -1 to 2. So the second piece is a constant function as well, and that is defined as f of x is equal to 2, and f of x is equal to 2 when x is in between -1 and 2, including the endpoint. So two pieces so far. Third piece, we would say this function is also defined as from 2 to 5, closed interval, defined as -1, again, for x is in between 2 and 5, including the endpoint 5, right? So some of you might say, well, first branch is the same as second branch. Do we need to separate them? I don't know. It depends on what you like, right? So you may end up combining those two as -1 for when, and then you will use your union or whatever your interval notation. But I think in this case it will be clearer to actually write three different pieces, because graphically you see three different pieces to it, and that is what we call a piecewise function when we use different output formulas for different pieces in the domain. Okay, so here we would see blue, red, and green. Okay, so let's say let's define this function, blue, red, and green. So we would say the function f of x is equal to, okay, we would have the blue piece, and the blue piece goes from -infinity to -1. So that would be for when x is less than or equal to -1, right? The red piece is for this part of the domain from -1 is less than x and x is less than 1. Now, how do I know not to include the endpoints? Well, my solid dots are either blue or green, not red, so I'm not including that in the red. And then the third piece is the green, and that is from 1 to infinity. So we would say when x is greater than or equal to 1. Now, how then do we find these formula here for these equations. Well, the red one is the easiest because that's the constant function. So that is f of x equal to 1 for the red piece. For the blue piece, we will have to find the equation of this blue line. And if you notice, the slope is up 1 over 1, up 1 over 1, up 1 over 1. So if you continue this up 1 over 1, your the blue line, the y-intercept for the blue line would have been at 2, and the slope would be 1. So then that equation is y equals to 1x plus 2, or we would say, well, f of x is equal to x plus 2 for the blue piece, right? Now for the green piece, the same concept here, going from left to right. This is a linear function with the slope of up, no, not 2, but up 3 over 1. So the slope is 3, and the y-intercept is, if we were to follow the pattern, go down 3, left 1, right? Down 3, left 1 is the same as up 3, right 1. That y-intercept would have been at -2. So the equation of this green line would be y equals 3x minus 2. So going to define our piecewise function, we would say f of x is going to equal to 3x minus 2 for any x that is greater than 1. So those are the three pieces, and that is how you would write the equation of a piecewise function. All right, let's practice finding function values in a piecewise function, right? So from previous lesson, you know that the f of 5 means the function value when x is 5, meaning your input is 5. So if your input is 5, which piece do you belong to? And you would belong to the third piece. 5 is greater than 2. So f of x in this case would be 2x plus 1, and that is 2 times 5 is 10 plus 1 is 11. So that would be 11. F of 5 is 11. Now what about f of -3? Same concept. You would have to go and see which branch you belong to. So when x is -3, we belong to the first branch, so that f of x is equal to x, and x is -3. Okay. F of 0. Well, where does 0 belong to? 0, let's say, here, that's including 0. So f of 0, you would go to this middle branch, and f of 0 is equal to -2 as it is being defined in this piecewise function. What about f of 2? F of 2, we're looking at the pieces here, and 2 belong here. So that would be 2x plus 1. So 2 times 2 plus 1, that will give 5. So f of 2 is 5. So when looking for a function value in a piecewise function, we do need to look at the different branches in the domain. All right. That is how we find function value. Now let's try to actually graph this. Okay, so there are 3 different pieces. The first piece is f of x is equal to x when x is 0 or less. So if we were to graph the actual graph of f of x is equal to x, that actually is a line, right? A diagonal line crossing here. And that would look like this, right? That would be your function y is equal to x. But we do not take the whole entire line. We only take the part where x is less than 0. So we don't have this piece here. We only go up to here. And this is an open dot because x is less than 0. Okay, so that's this piece right here. Now for the second piece, that is a constant function, negative f of x equal to -2. So that would go a horizontal. That would be a horizontal line, -1, -2. You are right here. Okay, so -1, -2 is here. And we are looking at closed at 0 and go out to 2, open. And that would be that piece here. Okay, the third piece in your function, I would use green. And the third piece go from 2 to infinity. And that would be the line 2x plus 1. Okay, now how do you graph a line that is way out here to the right-hand side? Well, remember, a line, you'll need a point and a slope, right? You know the slope is, in this case, slope is 2, right? What point are we going to use? Well, instead of using the y-intercept, which is at 0, 1, that's going to belong to the red part, right? So we're not going to go there. We're going to go where our starting point is, which is at x equal to 2. When x is equal to 2, y is 5. And then we will use the point 2, 5 and the slope of 2 to graph that line. And that's a lot faster than having to graph the whole entire line and then erase the part you don't need, which is fine as well if that's what works for you. Okay, so 2, 5, which is this point, 1, 2, 3, 4, 5, this point right here. Okay, and the slope is 2, so we will go up 2 over 1. So we will have this line right there. And that are the 3 pieces of our function. All right, now given a piecewise function, let's practice looking at the domain, range, and all of the other things that we have learned before. Okay, so the domain is the set of possible input. In this case, we are moving along the x-axis. So that would go from -infinity all the way to here, open. That's for the piece on the left. But guess what? This one little dot right there is going to close up this part of the domain. And then the right piece keep moving, right? So the domain in this case is -infinity to +infinity. Okay, now let's look at the range. The range is the set of possible output, or we would say the y value, going from bottom up because smaller y value is on the bottom. And that would be -1, -2, -3. We are collecting all the y value of all of these points that belong to the function. And so this left piece right here will give you all the y value going all the way up. right? And not that I'm not paying attention to these, but the fact that these this left right here already cover this part right here. You see this point right here is gonna map onto here, which is fine. We already include that. And all of these points here will map onto here, which we already include. So the range in this case would be from -3 to infinity and opened at -3 because this right here is an open dot. Okay, increasing, decreasing, or constant. Well, increasing, decreasing, you would have to go from left to right. Going from left to right, this function is not increasing at all. Okay, it is decreasing over the interval here on the left hand side, going from here to here. That is decreasing. So we would say decreasing from -infinity to 1, 2, 3. And when talking about increasing, decreasing, we're talking about an open interval I, right? So yeah, the open interval is from -infinity to 3. And it doesn't make sense to talk about increasing, decreasing when you have just one dot, right? And then from 3 to infinity, your function is staying constant. All right, so this right here, h of -10. Well, where's -10? The function value when x is -10. 1, -2, -3, -4, 5, 6, 7. Oh, I'm out of room. So what are we going to do? Well, use algebra. What does that mean? Find the equation of this line. The equation of this line is y equals, the slope is down 1, right 1, down 1, right 1. So the slope is -1x, and the y-intercept is at 0. So that's just -x. So h of -10 is just the same as -1 multiplied by x, which is -10, and that is +10. And if you think about following this function up, it will go up to 10. Okay, same concept. H of 46. Oh my gosh, that's way out there. But wait a minute, we know what this function is doing by looking at the equation of this piece here, where that h of 46 belong. So the equation here is y is equal, that's a constant function, 1, 2, 3, y equals 3. So h of 46 is going to equal to 3 because it belongs to that branch of the piecewise function. And that is it for today.